Good morning, Trig. We are going to be covering lesson 46, and so I'm just going to jump right in. So 46.A covers complex roots. And remember, complex roots involve a real part plus an imaginary. So you've got your real, and then your term with I, your imaginary term. Now, complex roots always occur in conjugate, that should be an A, pairs. Meaning if I have 6 plus 5i, its conjugate would 6 minus 5i. If I had negative 1 minus 2i, the conjugate would be negative 1 plus 2i. Please pay attention to what's changing here. It is not anything but the middle term that changes. Okay, so it goes from minus to plus or plus to minus. Okay, so these are conjugate pairs. So this section has us writing equations with complex roots. So I'm going to do a couple examples with you. So write the quadratic equation with an LC, a leading coefficient of 1, whose roots are, and then we'll do 3 examples. Okay, so sorry about that cord in the background. So part A, here are roots 1 plus 2i. Now, if they only give me 1, they might give you both, but if they give me this root, then I automatically know that 1 minus 2i is a root because I told you they come in conjugate pairs. So they might give us both, they might only give us 1, and it's up to us to know that there are 2 of them. So if these are my roots, the first thing I'm going to do, step 1, is I'm going to write my factors, beginning with an x. So I have x. I'm going to cover this one up. So the opposite of positive 1 would be x minus 1. Opposite of positive 2i is minus 2i. Next one, x. I always begin with x. Opposite of positive 1 is minus 1. Opposite of negative 2i is positive 2i. Okay. And then step 2 is to distribute the factors. Okay, so above this I'll write if you're a steps person. So x times x, and if it helps you, you could distribute or use box method. And I'll do both so you can see both. For some people, the box method is better because you tend to be more organized when it's in a box. So I would have a column for each term, and I would have a row for each term. Okay, so you could either use the box method or you could distribute. It's really whatever you're comfortable with. But either way, I should get the same answer. So x times x, I get x squared minus 1x plus 2ix. So that's from distributing that first term all the way across. Now I would distribute the negative 1, so negative 1x plus 1 minus 2i. I'd keep going. Now I have to distribute the 2i, so I'm going to keep writing my terms. I've got negative 2ix plus 2i minus 4i squared. Okay, so now know that when I distribute these, all i's should cancel. Okay, so I'll make that note somewhere. When multiplying conjugate pairs. It's like multiplying a difference when multiplying conjugate pairs. All I terms should cancel. So if you are left with an I, then you did something wrong. Okay? So I am now going to combine like terms. So hopefully you remember I squared makes this a positive. So now I have x squared. I'm going to combine my x's. So negative 1x minus 1x is negative 2x. The 2ix, those cancel. Negative 2i and positive 2i cancel, and I'm left with a positive 1. Hopefully you can see that I have a positive 1, and I have a positive 4. So that makes positive 5. So there is my answer. Now, you could do the same using the box method, so multiplying like a multiplication chart. So x times x is x squared. This is negative 1x. 2ix, I just write them next to each other. Negative 1x, positive 1, negative 2i. Negative 2ix, positive 2i, negative 4i squared. I squared makes this positive. And then from there, you would combine like terms, like these are gone, and you are still left with the same terms to combine. The nice part about this, though, is it keeps it condensed and organized. You won't miss anything. So this also gives me x squared minus 2x plus 5. So you pick which method you like best, box method or distributing, but know that all I terms should cancel. All right, next one. So part B, I have 4 plus I, and I'm going to make this a negative 4. And so if negative 4 plus I is a root, then negative 4 minus I. So notice I did not change the sign on the 4. I'm only changing either the difference or the sum. The middle sign is the only thing that I should be changing. So first we're going to write our factors. So x plus 4 minus I, I'm just changing the sign of each. X plus 4 plus I. And then you pick a method in which you prefer. I'm going to distribute. So x squared plus 4x plus ix. Okay, I distributed that first x. Know that since I'm distributing, I have 3 terms in here and 3 terms in here. I should end up with a 9 down here. Now I'm going to distribute the positive 4. So again, 4x plus 16 plus 4i. Last, negative ix, negative 4i, negative I squared. Now, if you'll notice, I always write numbers before letters. So instead of x4, I write 4x. But when it comes to having 2 letters, I typically write them in alphabetical order, and I stay consistent. I always write them in alphabetical order. And that way they look like terms because they're written in the same order. So all the I terms should cancel. This one cancels because it is a negative 1. So this is actually positive 1, right? Because I had a negative I squared equals negative times negative 1, because I squared is negative 1, and that's why I ended up with a positive 1 here. So I'm going to combine my like terms, or I can combine the 4x's. And then I can combine my constants. And then I also, so ix cancels, so does 4i minus 4i. So all my i's should be gone. My answer is x squared plus 8x plus 17. One more, just so that man, my notes look so good, guys. These are the kind of notes I dream of taking in class. But that takes more time when you're here. All right, so here are my roots. My roots are 3i, which automatically means that the conjugate, negative 3i. Now notice here there is no real part, and that's okay. So don't add a 0, don't add a 1. It's okay to just have an imaginary part. So my factors would simply be x, the opposite of positive 3i is minus 3i. The opposite of negative 3i would be x plus 3i. So I have less to distribute here. So x times x is x squared. X times 3i, I like to keep it in order, number and then alphabetical order. Negative 3i times x is just negative 3ix. Negative 3i times positive I is negative 9i squared. Now, off the bat, I know that I squared is negative 1. Negative 1 times negative 9 changes this to positive 9. These cancel because they're opposite, 3ix minus 3ix, and I'm left with x squared plus 9. Okay. So that should cover 46 point A pretty well. We are now going to jump into 46 point B, which is factoring over the set of complex numbers. Now, I'm not sure why this book titles the way they do. We're actually not going to do a ton of factoring in this. Most of the time, it says factoring, but most of the time I'm just going to use the quadratic formula because it's easier. It's really hard to factor when you have terms that don't make sense. So I'm going to do 3 examples here so that you can see how to do this. So this would be example 2. And here are the directions that your book would give you or a test. Factor the following over the set of complex numbers. And what that means is, it means that you are going to have I in your answer. That's why it says a set of complex numbers. And set because we know that they come in conjugate pairs. And there might be some things we can factor out like a GCF, but over the set of complex numbers, you should have a pair of conjugate answers. Okay. So in part A, we're going to factor or solve 2x squared plus 6 equals 0. Now, you could kind of factor this, right? I do have a GCF of 2, and so that would leave me with x squared plus 3. Okay, if I want to use the quadratic formula, this is really this is x squared plus 0x plus 3, right? I have a is 1, b is 0, and c is 3. So x equals, the quadratic formula is b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now from here it's pretty simple, right? This is just 0. So I have x equals plus or minus. This is just 0 minus 12, so the square root of negative 12 all over 2. So I'm going to simplify, and you have to simplify. I'm going to simplify my radical first. So plus or minus 2i root 3. Now I'm getting that because I have a negative 1 times 4 times 3. Negative 1 is the I. Square root of 4 is 2. And that's where I'm getting 2i root 3 all over 2. Now I can reduce my fraction. So second, reduce fraction, right? 2 over 2 is 1. So my answers are plus or minus I root 3. Now, a couple of things though. I have to write my answer as factors. So, third, write answers as factors. Okay, so here we go. I had a GCF of 2. Factors are x plus I root 3 and x minus I root 3. So let's go over this. This is my GCF. It has to stay on the outside. And these are my 2 solutions from the quadratic formula. And those are my answers. Those I've wrote it as factors. So that's where the word factor the following over the set of complex numbers. First solve it, then write your answers in factored form. All right, part B, and I might have to go to the next page. Let's see if we can fit this here. So 2x squared plus 4x plus 8. So first I'm going to take out a GCF of 2, and I'm left with x squared plus 2x plus 4. Now the reason I'm using the quadratic formula to solve this is there's no factors of 4 that would add up to be a positive 2. So quadratic formula, right? A is 1, B is 2, C is 4. So x equals a negative b plus or minus b squared minus 4 times a times c. I expect you guys to have the quadratic formula memorized, or you can Google it, but don't mess it up, okay? You're in trig. We are far, far after messing up the quadratic formula. Now remember, I'm factoring this over a set of complex numbers, so I'm going to get I. If you don't get I, they've told us we're going to. If you don't, then we did something wrong in our quadratic formula. So this is negative 2, right? Plus or minus. This would be 4 minus 16. So again, negative 12 all over 2. Remember, you have to simplify this guy first. So we simplified negative 12 up above. That's 2I root 3 all over 2. Now we can reduce these 3. And so I get x equals negative 1 plus or minus 1I root 3. So then I'm going to write these as factors. So let's start with my GCF, because greatest common factor. So if I took it out, but it was still a factor of this original problem. Now, when I write my factors, remember it's the opposite. So x plus 1. Opposite of positive would be minus I root 3. Next factor, x plus 1. And then the opposite of the x plus 1. And then the opposite of that minus would be plus I root 3. Remember, you should have 2 factors where the i's are opposite. The first term isn't. I hope you see that pattern. And then these are our answers, our factors. Last one, and we will be done with this section. So part C, sorry, you can't see that. Part C, x squared plus 2x minus 5. Now in this one, there is no GCF. So I'm just going to start with the quadratic, right? A is 1, B is 2, C is negative 5. So x equals a negative b plus or minus b squared minus 4 times a times c all over 2 times a. So I've got negative 2 plus or minus. This would give me 4 plus 20. This will not be giving us I, so I apologize for saying I thought they all did, but apparently this isn't, because you can have a complex number where I is 0. My apologies. So the square root of 24 all over 2. Now which part can I reduce first, the 2's or the 24's? And if you were here, you'd be like, the radical, the square root of 24. You are correct. I have to simplify this first. 24 is the same as the square root of 4 times 6. The square root of 4 is 2. So I end up with negative 2 plus or minus 2 root 6 all over 2. Now I can reduce these guys. Okay? So I am left with x equals negative 1 plus or minus 1 root 6 over 1. right? But I don't need all those ones. Just the first one, -1 plus or minus the square root of 6. So let's talk about the ones we need and the ones we don't. Get it? So I must write -1 because -1 is being added and subtracted, and that does change the value of a number. -1 plus 4, right? It changes the value. But 1 times root 6 does not change the value, so I don't need to write it. Divided by 1 doesn't change the value, so I don't need it. So now we're going to write our factors. X opposite of -1, opposite of positive root 6, opposite of -1, opposite is negative root 6. And so those are my answers. Those are, I guess, technically in complex form because the complex number is 0. For homework, so sorry, that sums up the lesson. For homework for lesson 46, we will skip numbers 3, 4, 6, 8, 11. Some of those come from the section we skipped, and that would be it.